To fine-tune or not to fine-tune? Well, that's the tech world's modern take on poetry, but today we'll talk about it from a different perspective, the business perspective. Reading through tech news every day, you probably encounter frequent mentions of fine-tuning and companies engaged in it. More and more businesses want to integrate AI into their workflows, but the promise of large language models making our lives easier and solving our problems eventually faces a stark realization that foundation models behind tools like ChatGPT aren't often enough for business, and you can't rely solely on them. You may then embody Prince Hamlet and ask the question that I asked at the beginning of this video yourself. So, is fine-tuning the only way to AI's promised land? Before we answer these questions, let's say what fine-tuning is. So in the context of AI, fine-tuning is a training technique that takes the model that was trained for one given task, then trains it on new data, let it perform for a new specific task. For example, taking an okay performing object detection model and then fine-tuning it to be an expert dog detector would be fine-tuning. Getting back to LLMs, Harvey AI is a company that fine-tunes and deploys models for the legal industry. It's a very specific field with unique terminology and jargon, and everything else that makes reading your job contract feel like studying foreign language beginner's textbook. It makes great case for fine-tuning because it's a niche where you want the model to perform very specific tasks like preparing legal research or writing legal documents. Oh, and it also has a ginormous amount of data you can train on. If you're a huge company like Allen and Overy, you can even train the model on your own company's data to achieve even more tailored results. Or even on particular clients' data. In fact, they already do this. So if I just get all my data in one place, feed the model with it, then can I expect the best? Well, yes and no. These models aren't called large for nothing, and training them is more intimidating than it may sound at first. There are a couple of dragons you need to kill on the way, from getting your hands on an LLM to tuning in to be your business expert. We'll talk about it in detail soon, but to even get to these problems, you need to solve another one. Get the data for fine-tuning. And we're talking thousands of high-quality data points. But even if you're lucky enough to have it, there's still no guarantee that you'll get the results you're hoping for. I don't want to say that fine-tuning is ineffective, because it definitely can be, but for most businesses that are exploring how artificial intelligence could work for them, this is not the best way to go about it. Let's start with the first premise of why out-of-the-box large language models aren't good enough for business. We've all seen headlines about ChatGPT doing college-level math or ChatGPT doctors. Sure, these LLM-based tools can achieve striking performance in some domains previously uncharted by AI, but a headline, well, it's just a headline, and these models fall short when faced with real business problems like dealing with an angry customer who requires a very specific information. Foundation models, like OpenAI's GPT family, are trained on diverse datasets to perform well on various tasks. The goal behind training them was to make them versatile, not domain experts. Therefore, they struggle with nuanced context of individual businesses. If you plan or already use AI, you probably employ it for a very specific task, such as automating answering your customers' repetitive questions. The industry you operate in, as well as every other industry, has a very specific nomenclature, and the general model might not have been trained on data specific to that industry, making it less effective in understanding and generating relevant content. If you're a lawyer, try to type a question related to the case that you're working on into ChatGPT, and you'll quickly realize that the responses are, well, not that helpful or accurate. In the best case, the answer may raise a couple of eyebrows, but in the worst case, you can even go to jail for that.
I wouldn't want to go to jail for that. Fine-tuning is one of the ways to get better results. It enables you to create a highly specialized private expert tailored specifically to your business. Where's the trick? First and foremost, fine-tuning requires a lot of data. The bigger the model, the more data you will need to fine-tune. Why? Because it has more parameters, variables that represent specific bits of information about your data, which need to be adapted to this new domain. The data in question needs to be very high quality, task-specific, and labeled. What does it mean? For instance, in the legal field, if you wanted to create a model which summarizes very long legal documents, a high-quality summary would have to be one which keeps all the specific terminology and relevant information, but is concise. Which means you will first need to gather enough data to teach the model what this specific terminology and relevant information actually is, and what a high-quality summary would look like in your view. In many cases, if no such dataset is available yet, you'd need to summarize all of these documents by yourself. The second issue is computational resources. Large models, those that would actually be capable of summarizing long bodies of text in a satisfactory manner, require a lot of computational resources to fine-tune. This may be a limitation, especially for individuals or organizations with limited access to computational resources. Another important aspect is transferability. The success of fine-tuning depends on the similarity between the pre-training task and the target task. That's why we refer to the law industry example. The law doesn't fundamentally change that often. Sure, there might be some additions, new laws, but on a principle level, the law is the law. However, most businesses nowadays are dynamic and their data sets constantly change. Think about e-commerce stores and they're constantly changing inventory, prices, discounts, and much more. What we learn from customers is that every single time what happens at the end is that a customer wants the AI to say X when it said Y. When you're fine-tuning, it's very non-obvious how to tweak your data set to make the AI say X instead of Y. And also, every fine-tuning improvement iteration takes time and money. Fine-tuning a model can also potentially impact the model's ability to transfer knowledge across tasks. We call this overfitting, where the model becomes overly specialized in fine-tuning data and performs poorly on new unseen data. It's similar to training a gourmet chef exclusively on making sushi and then suddenly asking him to bake a chocolate cake. Instead of a nice dessert, you might end up with a, well, creative and bold, but rather disgusting concoction of fish, seaweed, and chocolate. A clear sign of over-specialization. Another one is safety, where the model might start displaying undesired behaviors after fine-tuning, which is especially true for models which have been aligned for safety before the fine-tuning process. Developers of LLMs invest significant effort to ensure that these models don't generate harmful outputs, such as suggesting illegal activity, and implement various guardrails that prevent that from happening.
So, for many business applications, the fine-tuning process may simply be an overkill. As you saw, small to medium enterprises often lack the resources to fine-tune models effectively. But more importantly, most business applications, regardless of the size of the enterprise, may just not need a highly specialized expert model. To illustrate this simply, imagine you open a small business. You will now need to do your taxes. Does that mean you should go through an entire university-level education in accounting? No. A few YouTube videos or doing your taxes for dummies will most probably be more than enough. The same goes for LLM adoption in most businesses. If you need an AI assistant that will automate your customer support, you don't need to build a custom model that's trained on your company's data and past conversations to achieve a really good result. Right, so if you don't want to fine-tune, then how can we have the specificity and the level of customization that's required if you want to use Gen AI in a business setting? We could use a method that lets you add your domain knowledge to the LLM, so it gives expert-level responses without the hassle of fine-tuning. This method is called Retrieval Augmented Generation, RAG, and it presents an innovative alternative to traditional fine-tuning. RAG combines pre-trained LLMs such as OpenAI's GPT with retrieval mechanisms that fetches relevant information from your custom knowledge base. Patrick Lewis, currently a research scientist at Cohere, in the research paper in which he coined the term with his co-authors, they even called the general-purpose fine-tuning recipe. Let's see how it works exactly and ask Zula again.
Imagine you're the owner of ShipIt, a FedEx competitor that offers international shipping services. Don't actually need to fine-tune an LLM on international trade law if all you want is an AI assistant that answers questions about customs and tax laws of different countries. If your customers are worried about duties on that AliExpress package from China and ask your AI assistant about it, here's what happens under the hood if you use this technique. Firstly, you created a knowledge base for your chatbot that comprises all your customs and import tax documents. Then, this knowledge base is translated into a format that's understandable by the model. This process is called embedding. It takes the text that you provided and translates it into a vector, a numerical representation conveying the meaning of the text. You can think of this vector as an arrow in space with some magnitude and direction, or just an array of numbers. After this process, it's stored in this form in a vector database. Now, when the user asks a question, his query is also converted into this numeric representation, a vector. The embedding model then compares this vector to the data that's in the vector database, so basically to your company's knowledge base. And when it finds a semantic match, it retrieves the related data, converts it to a human-readable format, and passes it onto the LLM. Finally, the LLM generates the final answer based on the retrieved words and its own response query. It may sound complicated, but you don't really need to know anything about it to use it in your business. As you saw, this approach allows the model to leverage external knowledge without the need for fine-tuning on task-specific data. We can't ignore the fact that most businesses are dynamic. and these policies change. Also, in the case of fine-tuning, we mentioned overfitting. By avoiding task-specific fine-tuning, RAG reduces the risk and ensures that the model maintains a more generalized understanding of language. That's crucial to keeping a natural conversational tone of your AI assistant. Even better, what if I told you you don't have to have your own copy of an LLM running somewhere on your servers? It can actually make use of it as a service. And there are many services right now that communicate with an LLM hosted by OpenAI, Cohere, or Anthropic servers, so you can leverage the benefits of pre-trained models along with the ability to retrieve and incorporate external knowledge dynamically.
So to summarize, we can say that RAG is for those businesses that want to catch the LLM wave without drowning in the complexities of fine-tuning. This makes it a cost-effective solution for businesses that are at the earlier stages of adoption of AI. If you're a big corporation, definitely explore fine-tuning as a way to customize your AI and make it more aligned to your needs. But well, most of us aren't. Using general-purpose LLMs together with retrieval augmented generation will allow you for more adaptable and flexible AI solutions. Well, it may even finally let you use AI in the first place. Don't get left behind. As always, thanks for today's chat and see you somewhere on the internet.